In this video we shall discuss how to manage transactions in triggers, stored functions and procedures. In the first task we have to create a trigger on books table to block insert operations on any transaction isolation level except serializable. The expected result here is that if an attempt to insert data into books table is made and the current transaction isolation level is not serializable, the trigger raises an exception and rolls back the transaction. In MySQL, the solution is the next. We have to create an insert trigger on books table, and inside the trigger first we have to detect the transaction isolation level, and this is how we detect that level in MySQL. Then we have to check this level. If it's not serializable, we have to roll back the transaction by executing such a command. By the way, here is an attentiveness test. There is some issue with this trigger. Please pause the video and try to find this issue yourself. Finally, to test the solution in MySQL, first we have to switch the transaction isolation level to something other than serializable, for instance, read committed. Then we have to insert a data in books table, and this query will of course fail. Next we have to switch the transaction isolation level to serializable and repeat the insert attempt, and this attempt will succeed. In Microsoft SQL Server we use the same approach. We are creating after insert trigger on books table, and inside the trigger the first operation is the detection of transaction isolation level, and this is how we detect this transaction isolation level in Microsoft SQL Server. Then we have to check this level, and if it's not serializable, this number 4 stands for serializable, so in such a case we have to raise an error and roll back the transaction. To test this solution in Microsoft SQL Server, first we have to switch the transaction isolation level to any level other than serializable, for instance, read committed. Then we have to attempt to perform insert operation, and this operation will fail. Then we have to switch the transaction isolation level to serializable, and then we have to repeat the insertion attempt. And this second attempt will succeed. And of course for Oracle the idea is the same. Here we also have to create insert trigger on books table, and inside the trigger the first operation is the detection of transaction isolation level. And this is how we detect that transaction isolation level in Oracle. Then we have to check that level, and if that level is not serializable, we have to execute such a command that will lead to transaction rollback. To test this solution in Oracle, we shall follow the same approach as for MySQL and Microsoft SQL Server. First, we have to switch the transaction isolation level to any level other than serializable, read committed for instance, and then we have to attempt to insert data into books table, and this query will fail. Then we have to switch the transaction isolation level to serializable, and then we have to repeat the insertion attempt, and this query will succeed. In the second task, we have to create a stored function that raises an exception if being called with implicit transactions autocommit enabled. The expected result here that if the function is called while implicit transactions autocommit is enabled, it raises an exception and exits. In MySQL, the solution is that simple. We only have to create the function, and we only have to detect if that autocommit is enabled, and if it is, we have to exit from the function and print an error message. As this task does not imply any other operations, we only put such command here, and in real-life situations, of course, you may put some useful code here. To test this solution for MySQL, first we have to enable implicit transactions autocommit, and then we have to call our function. Of course, according to the task, this attempt should fail. Then we have to disable the implicit transactions autocommit and call our function again, and this attempt will succeed. For Microsoft SQL Server, this solution is a little bit different. The first difference is that this DBMS does not provide an easy way to detect if that implicit transactions autocommit is enabled or not, but we may use these parameters and their combinations to finally find out that information. The second difficulty here is that Microsoft SQL Server does not support neither raise error nor rollback transaction statements inside functions, and we have a function here. But there is a workaround. We may try to convert such a string into an integer. And of course, this string may not be presented as integer. That's why this operation will fail and the whole function will be stopped. To test this function in Microsoft SQL Server, first we have to enable implicit transactions autocommit and we have to call our function. And this attempt, of course, should fail. Then we have to disable implicit transactions autocommit and call our function again. And this attempt will succeed. The solution for Oracle is not a real one. There is no such thing as autocommit in Oracle at all. And also please don't confuse your IDE settings with DBMS capabilities. That's why we have nothing to do here, nothing to check here, we may only print some debug message. And if we want to test that non-real solution for Oracle, we have to enable the server output in order to see debug messages, and then we have to call our function. And of course, this attempt will always succeed. In the final task here, we have to create a stored procedure to count all records in a given table the fastest way possible. That means that our procedure should not wait for any other query completion. The expected result here is that the procedure should use the lowest transaction isolation level possible to avoid any delay due to concurrent transactions execution. For MySQL, we have to create such a procedure with two parameters. The first parameter should contain the table name and the second output parameter should contain the result, the rows count. Inside the procedure body, we have to set the transaction isolation level to the lowest level possible in this DBMS. Then we have to compose the query to count rows in a given table. Then we have to prepare the executable statement and to execute that statement. And finally, we have to return the result. To test this solution in MySQL, we have to call our procedure passing the table name and the variable to store the result. And then we have to select the result of the procedure execution. For Microsoft SQL Server, the idea is the same. We have our procedure, we have that input parameter with table name and that output parameter with rows count. Then we have to switch the transaction isolation level to the lowest level possible. Then we have to compose the query to select rows count from a given table. Then we have to execute the query and to return the result. To test that procedure in Microsoft SQL Server, first we have to declare a variable, then we have to execute our procedure passing a table name and that variable here, and then we have to select the result of the procedure execution. And of course, for Oracle the idea is the same. Here is our procedure, here is our table name and the output parameter to store the rows count. Inside the procedure body, we have to switch the transaction isolation level to the lowest level possible for this DBMS. Then we have to compose the query to select row count from that given table, and we have to execute that query, and we have to return the result. Finally, to test that procedure in Oracle, first we have to declare a variable, then we have to execute our stored procedure passing such parameters, and then we only have to print the result of our procedure execution.